Okay, hello I'm Lawrence Chen, and this is Lab 2. So we're gonna do a half adder and later full adder. So as usual, the red wires are representing the live wires VCC, and the black ones are the ground. So there will be two outputs. One is the sum, which here we are using a purple wire, and one is the carry, which we're gonna use the pink wire. And our two ICs are 7486, which is an XOR gate, and a 7408, which is an AND gate. So we have two inputs here. I'm going to represent using the blue and the yellow wire. Just going to loop it this way so that it looks tidier. Okay, so let's run. We'll start with, actually, no, let's start with 0, 0. So half adder 0 plus 0 should be 0, which no bulbs are lighting up, which is correct. We'll just put the blue to 1 now, and we see that the sum bulb lights up. So 1 plus 0 equals to 0, 1. And we're gonna swap them. So now is again 0 plus 1. And the sum bulb is the only bulb that lights up again, so 0 plus 1 and 1 plus 0 is the same. The answer will be 0, 1. Now we're gonna do the 1 plus 1. So okay, now instead of the sum bulb, the carry bulb lights up, which means 1 plus 1 in binary equals to 1, 0. Okay, and that's it for the half adder. We'll move on to the full adder. Well, I improvised this circuit from the half adder and changed a bit of the color here and there, but it's mostly the same, except this time I added a 7432, which is an OR gate into the circuit. And let's so I'll take some time to explain this. We still have the two inputs, but now we have a third input, which I use this turquoise wire. The third input also enters the XOR gate, or we call it a CIN, and the first input A for the second wire will be this CIN. The input B for this second XOR gate will be the output of the first two inputs. And also the output of the first two inputs will also be sent in as another input to this 08 gate, which I will also map this scene inside of this 08 gate, and we will send both outputs. First one is the A to A, B to B thing, and then the second one is the new output into as the first and second respective inputs of the new OR gates, and will lead to the carry, where the sum, instead of just coming out directly from the two inputs, now the sum comes out from the new gate we've added into this 86. So yeah, let's just give it a try. This one will take a while. First, let's set everything to 0, 0, 0. Sorry about that. 0, 0, 0. And yeah, no bulbs lighted up because 0 plus 0 plus 0 equals to 0. Now we will turn this to 1, and we see that the sum bulb lights up but not the carry. So 1 plus 0 plus 0 equals to 0, 1. Okay, then we will change to the yellow wire becoming 1. And we have here as same, the output is 0, 1 because 0 plus 1 plus 0, and that's 0, 1. And if we turn this back to 0 and bring this down to 1, we should expect the same, which is, yes, we have it, 0, 1. So yeah, as same before, as long as if only one of these three inputs is a 1, so the output will definitely be 1. Now let's see if two inputs have the value of 1 and the one input have the value of 0. So this time only the carry output shows 1 and the sum output is 0, because 1 plus 1 plus 0 equals to 1, 0. then we bring this up and bring this down. Again, with two ones and one zero, the carry output shows 1 and the sum shows 0. And one more, sorry, we'll leave this here. We're just gonna swap these two. So now 0 plus 1 plus 1. And yes, the sum shows 0, the carry bit shows 1. So yeah, 0 plus 1 plus 1, the answer is still 1, 0 in binary. And finally, when all inputs are 1, the output will be both the sum and carry bits show an output of 1. Because 1 plus 1 plus 1, in binary the output is 1, 1. And that's it for full adder and half adder. This is lab 2. Bye bye.